This is an example of project part two. These are the things that we're trying to find. The mass in kilograms. So you have your three planets. I picked one particular planet, um, which was not assigned to anybody. Anyhow, this is like the last one. Mass C is 22.25 Earths. So that's times the mass of Earth, and that's what that means. And then the radius is 0.448 times the radius of Jupiter. All right, so what we're trying to figure out is the mass of each of your three planets in kilograms, what the radius is in kilometers, and then we're going to convert the radius to meters, and then we're going to use we're going to use this equation right here. Let me write it out. Grab my stylus. To figure out the volume of any sphere, I'll do it down here. Oops, didn't switch to the pen. The volume of any sphere is four thirds times pi. So it's four third pi, and the radius to the third power. All right, so that's the volume. That's how we're going to get the volume information. So the radius has to be in meters, and then of course the density, which is really what we're looking for. The density, and the density is going to be in kilograms per cubic meter. So the density is going to be whatever the mass is in kilograms divided by the volume in cubic meters. Of course, this equation, when the volume is in meters, when the radius is in meters, when you cube that, that changes it into cubic meters. All right. Just to give you a sense of the density of things, the density of liquid water, right? Fresh water, right? So density of H2O, right? So not salt water, because that's slightly more dense, is 1,000, right? 1,000 kilograms per cubic meter. All right. So that's so we'll see what our densities are, and often we'll compare it to liquid water, liquid fresh water. All right. So let's start this problem. I actually picked this one on purpose because it's a mixture between the mass in terms of Earth and the radius in terms of Jupiter. So that's what you're seeing when you look at your three planets. You'll have what the mass is. Sometimes it'll be some number times Earth, and then sometimes it's some number times Jupiter. If it's times Earth, you use the mass of Earth as this number, the 5.97 times 10 to the 24th, which, by the way, a lot of times, and don't do this for this project, but a lot of times we simplify that to 6 times 10 to the 24th. Anyhow, and then if the mass was the mass of Jupiter, notice Jupiter is much more massive. If this was 3 times the mass of Jupiter, you'd say 3 times this number, 1.90 times 10 to the 27th. And let's see. And then if your radius is some number times Earth, you use the radius of Earth, which is 6,378 kilometers. That's the average radius of our planet because it's not a perfect sphere. Anyhow, for Jupiter, you take whatever the number is and you multiply it times this number, which is the radius, the average radius of Jupiter, 71,492, and that'll pretty much get you through that plus these two equations. This equation for well, you got to start with this one. This one for volume, where R must be in meters, and that's why we convert R to meters. And then this one where this is, of course, the density, that symbol right there. This is lowercase rho on the Greek alphabet, and that stands for density, and that's mass divided by volume. All right, and so let's do some of these problems, and Yeah. So the first one is, what's the mass in kilograms? So this is my sample one. This is going to be 22.25. All right. So let me write that down. Right. So this is my mass C. Right. So mass of planet C for me. I just picked that one because because there was a mixture between Earth and Jupiter sizes. Sometimes they'll both be in terms of the Earth. They'll both be in the terms of Jupiter. So anyhow, so it's 22.5, 22.5. I'm sorry, 22.25. Sorry about that. 22.25, and that's a decimal point. That doesn't really look like a decimal point. And then of course times, and so see it's times the mass of Earth, right? And there's the mass of Earth, right? Right. So it's times 5.97 times times 10 to the 24th. All right, 10 to the 24th. It's supposed to be a 2, not a Z. All right, and so I just did that a moment ago in my calculator, and so I get, I'm actually going to, so you can write times 10, or you can use, the Blackboard language for things in scientific notation. So I'm gonna round this to 3 places past the decimal because if you look at the problem, it says the assignment, the project part 2 says to round it to 2 places. Round these numbers, the density and these numbers down here, the density and the volume to really the density to 2 places past the decimal. So we'll start with 3 places past the decimal. So anyhow, that's 1.328, and it's times 10 to the 26. So I'll just write capital E, just like we do in Blackboard, 26. Right? So that's time, and of course that's kilograms. That's kilograms. All right, and so that number would go, in that would go right here, right in here. So that you'd put that. All right, and so what's my radius of C? All right, so well that again is 0.488. All right, so it's 0.488. And then it says to multiply that, that's an 8, sorry, times the radius of Jupiter. And so we do that. And so what I'm doing right now is what goes right here, the radius of your particular planet in kilometers. So you multiply that times 71,000. So let me write that out. 71,492 kilometers. All right, and so this will give us a number in kilometers, which I've already done. So this comes out to be, and I'm going to go 3 places past the decimal, just like I did with the mass. So it's going to be 32,000. So it's smaller than Jupiter, less than half the size of Jupiter. 32,000, 28 point 416. 416. And of course, that's kilometers. All right. But of course, there are 1,000 meters in a kilometer. Let me write that right here. So it's just 1,000 meters is 1 kilometer. All right. So, anyhow, all right. So I'm going to rewrite this, and then we're going to use this equation for the volume. So actually, I'll just do it right here. All right. So I mean, all this amounts to converting it. So what I'm doing now is the radius in meters. So this part, right? So I've done the first part for what the kilograms are. So I put this number right here. For the radius in kilometers, I put that number right here. Now I need to know the radius in meters, so you just simply multiply this number by 1,000. And so all that does is moves this decimal place 3 places to the right. And so this becomes 3, 2, 0, 2, 8. All right, and then so that's why I went 3 places past the decimal. 416 meters. All right, so that's what I'm going to use in this equation right here, the volume equation. All right, I'll do that in just a moment. Let's see, how much time do I have? Okay, good. All right, so I'm going to set this up, and we're going to just use these two numbers, and we're going to use these two equations to get these final two, what the volume is in cubic meters, and then of course we'll take whatever the volume turns out to be. We'll take this number divided by the volume in cubic meters, and then we'll take a look and see, hey, is this particular world, or this planet, in this case planet C, is this more dense than liquid water or less dense than liquid water? All right. So this, of course, is the volume equation. It's 4/3 times pi times the radius raised to the third power. So just a moment ago, we figured out what the radius of our planet C was in meters. Now we have to cube that, okay, and then multiply it by 4 pi over 3. All right, so I'm going to cube it. So make sure you know how to do that on your calculator. Times 4 pi divided by 3. All right, so here's what I get when I do this. So I get, I'll go 3 places past the decimal. All right, so it's going to be 1.376. Right, so please try to do this. I didn't leave myself enough room. E. So this is the E, and then right below it, I'm going to write to the 23rd. Right, E23. All right, I'll write that again just so it looks a little bit better. So here it is. So it's 1.376 E, or times 10 to the 23rd, and of course that's meters cubed. All right, so that's a better. And then of course the last part is the density. All right, so the density is going to be our mass, which the mass has to be in kilograms, divided by the volume, which of course we just calculated the volume in cubic meters. And then remember, the density of liquid water is 1,000 kilograms per cubic meter. All right, so let's see. Did I write down what the mass was? I hope I did. I think I did. Yes, I did. All right. So the mass of my planet C. All right. Remember, you're doing this 3 times for your planet A, planet B, and planet C. All right. Anyhow, is 1.328 times 10. I'm mixing these up between the E, the way that we draw it, times 10 to the 23rd kilograms. And remember, it means the same thing, whether you use the capital E or the times 10. It means exactly the same thing. So the volume is just this number right here. So it's 1.3. That's. I didn't mean that little thing right there. Sorry about that. So it's 1.376 times 10 to the 23rd. All right. Very good. All right. So let's do this calculation. All right. Before I pause this, I made a mistake. This should have been times 10 to the 26th. Anyhow, the mass. So I've written it correctly now. When you divide this number by this number, you get. So actually, in my calculator, so this is 965 point. Actually, I got a 0.11. just to let you know. Well, point one